Hey everyone, welcome back. Last we talked about vertical shifts, and in this video, we're going to go over what we talked about as far as phase shifts and a few more examples. So last time we realized that sine and cosine, they overlap. Notice that our sine graph in red starting at 0, 0 can become cosine of x if we shift it to the left or to the right. So first off, we started by noticing that our sine graph can shift into cosine and cosine can shift into sine. So if we're trying to move the cosine graph up here, starts at the point x is 0, y is 1, I can shift it over 1, 2, and end up at this point right here. Again, from my cosine graph, I can start at this main point and shift it over 1, 2, and end up on my sine graph. My minimum value at x is pi, y is -1, I can shift it over 1, 2, and end up on my sine graph. And again, my 3 pi over 2, comma 0 can be shifted over 1, 2 positions and end up on my sine graph. So shifting all of these points to the right by like 2 units or whatever, will end up making our cosine graph transform into the sine graph. Now, it isn't necessarily 2 units. I actually need to be a little bit more precise. So although it's moving over 1, 2 spaces, I need to look at my units of measure. Each individual space represents pi over 4. So 2 pi over 4 is pi over 2. So really, I can represent the cosine graph as being shifted to the right by pi over 2 units and ends up as sine. And we can use this idea to transform all of our trig functions. Shifting left or right is called a phase shift. No, Mom, it's not a phase, but it is a phase shift. A phase shift just means we're moving horizontally, the horizontal distance that a function is moved. So again, here we can see in red is our sine graph, and we can shift it over horizontally from left to right. We can shift it over however many this units is and change my graph. So if I were to describe this shift right here, I notice that things are moving. That's not a good point. This point is moving over, and I want to know how many so that I can describe my phase shift. Again, we are going to need to look at the units of measure. And right here, there is not a value. However, it's halfway between pi over 2. Halfway between pi over 2 is pi over 4. So if I were to describe this shift in words, this phase shift in words from y is equal to sine x, I would say that y is equal to sine x has been shifted to the right by pi over 4 units. That's in words, how I would describe that shift. It's been moved to the right in pi over 4 units. And if we're working with a phase shift, we're specifically only working with the value of C. So remember, A is our amplitude, and it's also vertical stretch or compression. B happens to be the number of cycles within 2 pi, but C is next to our X, the thing we never trust. C is next to our X, and that's also been the type of transformation that moves left and right. So with our phase shift, we're going to be adjusting value C. And then lastly, we have D, which is what we talked about last time, and that is a vertical shift up and down. So if we're moving things over by pi over 4 units to the right, my equation is going to be shifted and changed next to x. But remember, we never trust our x. So if I'm going to come up with an equation for this, I know that it's sine to begin with because it started at 0. So my equation is still going to be y is equal to sine of x. But since I'm shifting it to the right, I'm going to subtract pi over 4. I'm going to subtract. I'm going to do the opposite. So if I'm shifting to the right, I should have a minus. How many am I going? Pi over 4 units. Let's do another one. Here we can see that the graph is moving infinitely in either direction. So how can we describe the shift of sine of x? Again, I'd like to highlight one cycle of sine starts at 0 and continues. It has to finish the entire cycle. It has to start at 0 and go up to the maximum, go back down to the minimum, and end at 0. So that is one cycle of sine. But how can I describe the shift of sine in words? And there's multiple ways that we can describe this. So if I want to shift sine, and I need it to go up first, I notice that if I shift it over pi over 2, I'm going down. That is not going to work. Pi over 2 is not enough. If I shift it over to pi, my function is still going down. That's not enough. If I shift it over to 3 pi over 2, now my function is finally going to be able to start at 0 and go up to the maximum, come back down to the minimum, and end at 7 pi over 2. So the length of this distance right here, when I start at 0 and I went all the way to the right, 3 pi over 2 is one of the shifts. I can say that I shifted sine to the right by 3 pi over 2 units. And if I shift my equation 3 pi over 2 units to the right, it's still a sine graph, but we're going to do x minus 3 pi over 2. Now, this isn't the only way to visualize the graph, and I'm going to use a different color. I'm going to use green. Okay, so that's one way if I'm shifting right. But what if I have a different perception? What if I think about this in terms of shifting left? If I'm shifting left, notice that I only have to go back pi over 2 units to the left, because again, my graph will start going up and then down and finishing its cycle of pi. So I can go in either direction. I could go right by 3 pi over 2 units and have a sine of x minus 3 pi over 2, or I could describe my function as moving left by pi over 2 units. And if I'm going left by pi over 2 units, then my equation is going to be y is equal to sine of x plus pi over 2. Remember, do the opposite of what you think. So if we're going to shift to the left by pi over 2 units, if we're going left by pi over 2 units, if I'm going left, I'm going to go in the opposite direction. I'm going to go positive pi over 2 for my equation. Let's do some more. And I'm going to challenge you guys to change your perspectives and see if you can figure out how far it goes to the left and how far it goes to the right. Here's another graph, okay? How can we describe the shift of this red graph right here, sine of x minus 2? It's been shifted down 2 units, but I'm only curious in the phase shift. How can I describe the shift left or right of the red graph? Well, the red graph starts at 0, 0, since it's a sine graph. It starts at, well, 0, negative 2. And I can see that if I shift it to the right by pi over 3 units, I can start and complete one of my cycles of sine. I can start and complete one of my cycles of sine. So if I shift to the right pi over 3 units, I will end up with a cycle of sine, and the equation of that would be y is equal to sine of x minus pi over 3. And remember, this graph already was shifted down 2, so that's minus 2. So if I shift right pi over 3 units, I'm going to subtract pi over 3 next to my x. Everything about this function stayed the same. Well, what if I change my perspective? What if I look to see how many do I have to move to the left, right? Starting at 0, 0. If I shift over this many, my graph starts to go down, which is not how sine starts. So it can't be that far. It's going to go all the way back here. And luckily, this point is described. That means this distance from 0 all the way back over here is 5 pi over 3. And I can see that this will finally start my new cycle of sine. right? So just like I said, I could move right pi over 3 units. I can also think about moving left 5 pi over 3 units. And my equation would then become y is equal to sine of x plus 5 pi over 3. Remember, this graph has already been shifted down to, because the midline is at -2. So it still has that -2. So if I'm going to go left 5 pi over 3 units, I'm going to have plus 5 pi over 3. Again, peep the fact that the original function was sine of x -2. That's why we have these -2 values on either side. And honestly, I could have kept going. Like, as far as figuring out if I wanted to continue going right, like I could have went pi over 3, but I could have kept going all the way to this value over here, which would have been 7 pi over 3. It would have started again. This would have been 7 pi over 3, and it would have completed another cycle of sine. So it really just depends on your perspective, which is why it's so important to write out the phase shift in words and then convert that to an equation. Here's another one, right? Now we're going to talk about cosine. How can I describe the shift of cosine in words? So if I take a look at cosine to begin with, cosine always starts up at 1, right? Or up above. So if I'm looking at cosine, I want to figure out how can I describe the shift of cosine? And if I move it to the right, how many units am I going before I can start my one cycle of cosine again? Well, that's going to be pi units. So the way I can describe shifting cosine is I can shift it right by pi units. And my equation for shifting it right by pi units is going to be cosine of x minus pi. Now, I do need to look at the amplitude of this function, and I notice that from the midline is at 0, the maximum height is 3, so my amplitude value is going to be 3, but the midline is right at 0, so this is my equation, 3 times cosine of x minus pi plus 0, or just y equals 3 times cosine of x minus pi. Additionally, I can think about this graph being shifted to the left too, right? I can see that if I shift it back this direction, I can also get another cycle of pi or cosine in. Here's a cycle of cosine, and I notice that I shifted it to the left pi over units to pi units as well. So I could shift it right by pi, or I could shift it left by pi units as well. The equation remains the same, except now I have y is equal to 3 cosine of x plus pi. So depending on your perspective, depending on how you're swinging it, you can go left by pi and you're going to add pi. Or if you notice that it's going right by pi units, you can have x minus pi inside your parentheses. And this one, honestly, I could have did it again. I could have said like, okay, well, not only could I have moved it over pi units, I could have started and moved it over 2 pi units, and again, started my cycle of sine, or cosine. So it's very easy to find infinitely many ways to shift these around. Here's another graph, cosine x of 1.5. Cosine x plus 1.5. We can see that the midline here is at 1.5 because the midline is the d value in our shift equation. Midline is d. And if I find 1.5, that is right here. Okay, so there's my midline. And the amplitude is still 1. It goes from 1.5 to 2.5. That distance is still 1. And I want to figure out how can I describe the shift of cosine. So the shift of cosine starts at 1 usually. So if I shift it over how many to start my new cycle of cosine, starts up and ends up, that's a little messy. I can shift this function right by pi over 2 units. And if I shift it right by pi over 2 units, my equation becomes cosine of x minus pi over 2. And remember, it had a midline of 1.5. So I can keep that. I can also change my perspective and think about, what if I move in the backwards direction? How many units do I have to move it backwards? So if I'm moving over pi over 2 units, excuse me, to get to the first cycle, if I'm moving it right by pi over 2, that was x minus pi over 2. What if I move left? And if I move left, in order to start my new function, my new cycle of cosine, I have to go all the way back to 3 pi over 2 units. And I found that right over here. So I can shift my graph left by 3 pi over 2 units. And therefore, my equation will become y is equal to cosine of x plus 3 pi over 2. 3 pi over 2 plus my midline 1.5. So if I'm moving it to the left, I'm going to add. If I'm moving something to the right in my equation, I'm going to subtract. How many? I've got to look at my x-axis. So how to identify the shift of a function given a graph? First things first, we got to figure out where our midline is. Note this value. That is your vertical shift up and down. That's the D in the equation. Then look at where the midline and y-axis intersect. Is there a sine or cosine nearby? Which one's which? We're going to highlight a cycle of sine and cosine and figure out if this graph has shifted left or right just by looking at that x-axis. Lastly, check our amplitude to see if we can find a matching equation or determine an equation of our graph. So here's a match the graph with its equation exercise. I have graph number 1 and graph number 2. In order to figure out the equation, first things first is we should look and determine the midline. So the midline, I'm going to do this in orange a little bit. The midline is the middle between the maximum height and the minimum height. So I notice that the maximum height of my function is 2 on number 1. That's my maximum height of 2. And my minimum height is -6. So that total distance, 2 and -6 is 8 total. So from the top or the bottom, halfway between there is 4 units. So here's 1, here's 2, here's 3, here's 4. Oh, would you look at that? That's where my midline is going to be. Halfway between the maximum value and the minimum value. Same thing if I work from the top, down 1, down 2, down 3, down 4. Look, we end up at our midline. So for this particular example, my midline for problem number 1 is that D is equal to, that value is -2. Okay, D is equal to -2. So if I were trying to determine, based on the equations on the left, which one has a D value of -2, that leaves me with only these 2 options. Now that I have a 50-50 chance, I need to see what kind of graph are we working with here. If I think about where the graph is starting, I notice that it starts at my midline and then goes down and up, which is almost like sine. Usually sine goes up and then comes back down. However, we might have a reflection here. Or notice that this cycle happens just a little bit further, right? If I move that sine cycle to the right over here, I am going to be able to start it. So it's definitely going to be sine. And how many did I move it over from this 0 point over here? How many did I move it over? I moved it over 3. So for graph number 1 is y is equal to 4 times sine of x plus 3 minus 2. Let's do graph number 2. Okay, first things first, we need to identify the midline. The midline is the center. And for this one, it's a little bit easier to see that it is right here. This value is the midline. It looks like that is 3. If this is 2 and this is 4, right in between there is 3. So in this instance, we have our midline. D is equal to positive 3. So this tells us that now we are working with the top 2 equations. If D is equal to 3, we're working within these top 2 equations because we have plus 3. And I have to determine on where, whether I have a graph of sine or cosine. So since I'm starting at my midline and I'm going up and down, that's definitely a graph of sine again, not cosine. Now I have to see, is this graph being shifted over to the left, pi over 2? Yes, it is. Or we could have thought that this was the cosine graph as well, because cosine usually starts up. Cosine starts up and then goes down and finishes up. And if I smooth that over, how many would that be? All right, last one, match the graph with its equation. Let's take a look-see here. Find our midline. The midline of the graph number 1 is right here. This midline is at 3. So we're working with either of these 2 equations. Now, there's nothing starting here at 0, but there is a graph that's starting up, right? Up here. And if a graph is starting up, it's cosine. So how far did I have to shift my graph to the right to end up here at this cycle of cosine? And if I'm looking at my x-axis, this is 2 pi. So right here is pi units. So maybe I shifted it over pi. I don't see pi units over here, so that's not going to work. But I do see that maybe something might be shifted over pi over 2 units. So could this have been shifted over pi over 2 units? It's a little tricky to see, but normally our sine graph would do the following, right? If we were working with sine, it would normally start at 0, go up to 1. Oops. Start at 0 and go up, and then come back down and finish by 2 pi, right? So if it's starting, I notice that I can move my graph over a little bit right here. And if the blue tick mark was pi, this is definitely pi over 2. So if I'm starting with sine, I can shift it to the right, pi over 2, which means my correct equation would be the second one. We're working with sine. It was not the first one because cosine moved over by pi units, and that was not an option from my multiple choice. In case you didn't start your homework, you do have 2 homework assignments. Homework number 12 is specifically on shifting our graphs left, right, up, down, or identifying our amplitude. And then you guys will also have homework number 13 to evaluate 6 trig functions coming soon in the next video. Thanks so much, you guys. Have a great day, and I will see ya in class. Bye.